Today's lesson is on coterminal angles, reference angles, and special angles. My learning objective for today is I can name coterminal angles, reference angles, and special angles by describing and using degree and radian measures. So let's start out with a coterminal angle is an angle that the terminal side ends in the same place. So we know that in standard position, the angles all start on the positive x-axis with the vertex on the origin. So to get coterminal angles, I'm going to add and subtract multiples of 360. So to start out with a 30-degree angle, to get a coterminal angle in the positive direction, I can add 360 degrees and get 390. Or I can take 30 degrees and subtract 360 and get negative 330. And you can see the angles all look the same. Okay, so let's practice a couple of these. Let's do some in degrees and some in radians. So I'm going to add and subtract 1 revolution. So that's 360 in degrees or 2 pi in radians. So, all right, let's start out with so I'm going to add and subtract 360. So I'm going to add 360. So that's 860 degrees. And 500 minus 360 is 140 degrees. So 140, 500, and 860 are coterminal angles. So to plot this, I know that my initial side is on the positive x-axis, and I'm going to plot the 140 because that's the easiest to understand. So here's 90 and 180. So 140 is somewhere in here. So 140, 500, and 860. All right, let's do the same thing with negative 60 degrees. I want to add and subtract 360. So I'm going to start with 360 plus it's negative 60. So that turns out to be 300 degrees. And negative 60 plus negative 360, which is negative 420 degrees. So I'm going to plot negative 60 because that's probably the easiest to understand. Here we go. So these are all coterminal. So here is 0 degrees and minus 90. So minus 60 is right here. Okay, so let's do this with radians now. So I'm going to do the same process, but this time, instead of adding 360, I'm going to add 2 pi. So if I want coterminal angles with pi over 4, I want to add 2 pi. So what I'm looking at is the denominator. So twice as many of the denominator. So if I'm talking about fourths, 2 pi is going to be 8 fourths. So if I simplify 8 over 4, that becomes 2. So I'm kind of going in reverse. I'm doubling it. So I'm going to take, these are fractions. So this is pi over 4. And I want to add 8 pi over 4. So I get 9 pi over 4. And I want to subtract 8 pi over 4. So 1 minus 8 is negative 7 pi over 4. Okay, so here is 0. And we said halfway around is called pi. I'm focusing on what the denominator is. So I'm setting this up as 4 over 4 pi. So if I divide this half a circle into fourths, I know this is pi over 4 here. Okay, let's do one more with radians. So again, I'm focusing on what's in my denominator. So I want to add twice as many of the denominator. So 6 pi over 3, since I have 3 in the denominator. So I have negative 2 pi over 3 plus 6 pi over 3 and negative 2 pi over 3 minus 6 pi over 3. So negative 2 plus 6 is 4/3 pi. And negative 2 minus 6 is negative 8 pi over 3. Okay, so I'm going to look at negative 2/3 pi and graph that. So here is 0. We said halfway around is pi. We're using the denominator, so that's 3/3 pi. And we're negative direction. So I want negative 2/3. So to go halfway around the circle, I want to divide that into thirds. So this would be 1/3, 2/3. So here is negative 2 pi over 3. Right here. Okay. Reference angle. This is probably the most important topic that we need to understand, is what is the reference angle. So the reference angle, most of the time we call it alpha, and it kind of looks like a script A. It is the smallest, it's always positive, acute angle determined by the x-axis. So everything is about the x-axis. So when we're talking about transformations at the beginning of the year, when I talked about stretches and compresses in relationship to the x-axis, this is what we're talking about. Okay, so we have a couple examples. So I want to set up for, I don't know what else to say, but we really want to focus on this x-axis. All right, so I want to draw each angle in standard position, and then I want to find the reference angle. So yesterday's assignment, we practiced drawing the angles. So today we're building on that, and we're going to add the reference angle. I'm going to label each angle as theta, and then the reference angle as alpha. So my angle is 150 degrees. So I know I always start on the positive x-axis, and I know this is 90, and here's 180. So 150 is over here. So I'm going to label this as 150. So the angle itself is theta, and then the angle to the x-axis, that is acute. So this is smaller than going this way. So this is alpha. So I want to know what alpha is. So I know if I add these two angles together, they total 180. So I know alpha is going to be 180 minus the 150. So I know alpha is 30 degrees. All right, let's try the next one, 315 degrees. So I know 0, 90, 180, 270, and 360. So I know 315 is in the fourth quadrant here. So the angle we plotted is called theta. So this angle is theta. And then the angle to the x-axis, that's acute, is alpha. So I know if I add all the way around, this is 360. So alpha is 360 minus the 330, or 315. 315. So alpha is 45 degrees. Okay, I'm going to do the same process with radians. Okay, so again, I am always interested in what the denominator is. So my initial side is always on the positive x-axis. I know halfway around is pi. I'm going to rewrite that as 1 based on the denominator. So I want to plot my angle at 4/3 pi. So I know this is 3/3 to get all the way around. So here's 1/3, 2/3, 3/3. So I know 4/3 is right here. So 4/3 pi radians. So the original angle is theta. So this is theta. And now I'm trying to identify the reference angle. So the closest acute angle is this way. So I'm going backwards this time. So how much is my reference angle? So if I know this is 4/3 and this is 3/3, I know that alpha is 1/3. So I'm just subtracting. All right, let's try last one. Can we do purple? Pi over 6. So I always draw the initial side on the positive x-axis. So here is 0. Here is pi. I'm interested in what the denominator is. So this is 6/6. So I want 1/6. So this would be 1, 2, 3, 4, 5, 6. So here is my angle right here. So this is theta. And I want to identify alpha, which is the smallest acute angle back to the x-axis. So going back is the same way I came. So it's okay. Theta and alpha can be the same angle. So alpha is also pi over 6. Okay, so how do I define these? In general, how do I find these if I'm talking about degrees or radians? So I'm just looking at my quadrants here. And I am starting with, I know that here I'm at 0, 90, 180, 270 and 360 degrees. When I'm talking about radians, these are 0. This is pi over 2, pi, 3 pi over 2, and 2 pi. So when I have an angle in the first quadrant, so if I have an angle in the first quadrant, here, this would be my theta, and this would be my alpha. So alpha always equals my angle theta in the first quadrant. When I end somewhere my terminal in the second quadrant, my alpha is going to be, I'm always talking about 180, so this is going to be theta coming here, and my alpha will be here. So here is my theta. So my alpha for degrees is going to be 180 degrees minus theta. And for radians, it's going to be pi minus theta. If I'm going to end somewhere in the third quadrant, so my alpha is going to be here. This is my theta. So my alpha is going to be, theta is larger, so theta minus 180 degrees, or theta minus pi. And if I end somewhere in the fourth quadrant, here's my alpha. It's because alpha is always going towards this x-axis. And my theta is here. So alpha is going to be 360 degrees minus theta, or alpha is going to be 2 pi minus theta. So I'm just adding or subtracting angles, and it's involved with either 180 or 360. Okay, we have some special angles that we are going to be interested in. And we're specifically interested in pi over 4, 45 degrees, which is pi over 4, 60 degrees, which is pi over 3, and 30 degrees, which is pi over 6. And we are getting these, and these are from our special right triangles that we talked about in geometry. So 45, 45, 90, and 30, 60, 90. So just kind of taking a look, let's fill in what these look like in degrees and in radians individually. So if I start out with in degrees, so this is going to be 0 degrees. I'm going to put the degrees on the inside. So 0 degrees, 45 degrees, 90 degrees. So I'm just adding 45. 135 degrees, 180 degrees, 225 degrees, 270, 315, and 360 degrees. And then let's add that in radians. The radians are actually kind of easier to count. So this is going to be 0, pi over 4, 2 pi over 4, which is simplified as pi over 2. So 1 is 0, 1, 2, 3 pi over 4, 4 pi over 4, which simplifies to pi, 5 pi over 4, 6 pi over 4, which simplifies to 3 pi over 2, 7 pi over 4, 8 pi over 4, which simplifies to 2 pi. Okay, so that's 45 degrees going around the circle. All right, let's do the same thing for pi over 3 and pi over 6. So in degrees, let's start with degrees first. So I'm going to start with degrees first. So here's 0, 60, 120, 180, 240, 300, and 360. All right, let's add in the radians. So 0 radians, 1/3, 2/3, 3/3, which simplifies as to 1, 4/3, 5/3, and 6/3, which simplifies to 2 pi. And let's do the same thing for 30 degrees, which is pi over 6. So do degrees first. So 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. All right, let's do the same thing for radians. So 0, 1/6, 2/6, which is 1/3, 3/6, which is 1/2, 4/6, which is 2/3, 5/6, 6/6, which is 1, 7/6, 8/6, which is 4 pi over 3, 9/6, which is 3 pi over 2, 10/6, which is 5 pi over 3, 11/6, and 12/6, which is 2 pi. So the biggest thing I would say is when we're making these, what's really important is I'm kind of thinking of a hole. Normally we would draw these as rectangles. So for instance, for this one on the fourths, I would think of it here, but I want you to think about fourths looking like this. And I have two of them. I have two of them that fit in the circle. Okay.